this video, we're going to solve inequalities that involve rational expressions, graph the solution sets, and express the solution set using interval notation. It says solve the following rational inequality for x. And they give us two quadratics in our rational function. And it says that it needs to be less than or equal to 0. So here's what we need to do. We need to understand that the numerator is going to give us the zeros for the function. So this is where our solutions could possibly lie, is in that numerator region. The denominator is going to give us some domain restrictions, and those domain restrictions we call, for a rational function, these are called asymptotes. And to find those asymptotes, you set the denominator equal to 0. So we're actually going to do two different things here. We're going to set the numerator equal to 0. So I'll put this in parentheses. Set numerator equal to 0. And we'll also do the same thing to find the asymptotes. We're going to set the denominator, set denominator equal to 0. So we're going to do two different things in this problem. We're going to start by saying x squared plus x minus 12 is equal to 0. So this is the numerator piece. And then for the denominator, we're going to do the same thing. We're going to say x squared minus 4x minus 12 is equal to 0. And we're going to solve each quadratic separately. So let's factor this. The factors of negative 12 that add to x would be, let's see, 3 and 4. So 4 and negative 3. So we're going to have x plus 4. X minus 3 is equal to 0. We're going to do the zero product property. So we get x plus 4 equals 0, or x minus 3 equals 0. So we get x is equal to negative 4, or x is equal to 3, and these are the zeros for the function, which are the solutions to the function. Now let's go back to the denominator here. Or I shouldn't say the solutions, they're the solutions for the numerator of the function. Okay, they're the possible zeros that would zero this whole thing out so that it would equal 0 here. Now the denominator, these are all the domain restrictions. So denominator, this is domain restrictions. Which the domain restrictions are the asymptotes. They're called the asymptotes. Basically, they're vertical lines that the function cannot touch. Let's find those. Let's factor this negative 12. The factors of negative 12 that add to negative 4 are negative 6 and 2. So we have x minus 6, x plus 2 equals 0. Zero product property. We get x minus 6 equals 0, or x plus 2 equals 0. So we end up with x equals 6, or x equals negative 2. And these are the asymptotes. Now what we're going to do is we're going to draw a number line. And we're going to mark all the asymptotes and the zeros for the function on this number line. And we'll do it obviously in order. Negative 4 for the 0 there. Negative 2. 3. And 6. And then we're going to pick numbers to the left of negative 4. So we're going to check different regions. We got 1, 2, 3, 4, 5 different regions we need to check to see if there are solutions there. So let's check using negative 5. We're going to check using negative 3. We'll use 0 in between here. We'll use 4. And then we'll use 7. Okay, now to do this, I'm going to slide up just a hair so we got plenty of room. we're going to have to take this rational inequality and plug each number in to see what we get. So to do that, I think I'm going to just use the calculator to do this, make it a little simpler for us. Otherwise we got a lot of writing. So we're going to say x squared. Actually, let's put the fraction in there. X squared plus x minus 12 over x squared minus 4x minus 12. Okay, so here's what we're going to do. Oh, hold on a second. I'm going to plug in -5, and I'm going to get some sort of inequality here. Then I'm going to plug in -3, right? 0, 4, and 7. So let's plug in -5 first. So we're going to go -5. I'm going to store it as x, and then I can click on this function. It tells me I get 8 over 33. So 8 over 33, remember, would be the left side of this inequality. 8 over 33 less than or equal to 0. Is that true or false? That's not true. So we're going to cross this out. Can't work. And then we're going to go and plug in -3. So we'll say -3, and we'll store it as x. And then we'll grab that function again. And this time we get -2/3. Let's write -2/3 less than or equal to 0. That is true. So this area is where we have some solutions. Let's do 0 now. So 0, store it as x. Grab that function. We get 1. So 1 less than or equal to 0. That's not true. So these are not solutions. So then we do the same thing with 4. 4, store it as x. Get -2/3 again. So -2/3 is less than or equal to 0. That is true. And finally, we'll plug in 7. So 7 stored as x. And grab that function one more time. 44 over 9 is less than or equal to 0. And that is not true. So these are not solutions. Now let's go through and figure the rest of this piece out with interval notation. So first of all, if you have asymptotes, these are domain restrictions. So 6 would be an open dot, and -2 is also an open dot. Because these are zeros for the function, and we have less than or equal to, meaning we can equal 0, then these two numbers can be solutions. So we're going to put closed dots there. That tells us that our solutions run from -4 to -2 with a bracket on the -4 and a parenthesis on the -2. Union, bracket on the 3 to 6 with a parenthesis. And this would be our solutions for this rational inequality. Let's do a second example. This one looks a little bit easier. We'll have a little less going on in this problem. So, first thing we're going to do is we're going to set, again, like we did in the previous problem, we're going to start with the numerator. And then we'll work with the denominator too. And we'll set the numerator equal to 0, so x minus 1 is equal to 0. And then we'll set the denominator equal to 0 as well, x plus 1 equals 0. We add the 1 over, we get x is equal to 1. This is a 0 of the function. meaning it's a number that will zero out the left side of that equation. And the denominator is a domain restriction, so if we subtract the 1 over, we get x equal -1. This is a domain restriction. And that means that it's an asymptote. Okay, so let's mark both of these on the number line, -1 and 1. Now before I start, because this is a 0 of the function, and this says greater than, not greater than or equal to, this cannot be a solution. And also I can take care of that same thing with the asymptote. The asymptote is a domain restriction. This cannot be a solution. So we're going to check the three regions to the left, in the middle, and to the right to see if they are solutions. So we'll start with -3. Then we'll use 0, and we'll use 3. So let's plug those in. We'll have -3 minus 1 over -3 plus 1 greater than 0. We'll have 0 minus 1 over 0 plus 1 greater than 0. And we'll have 3 minus 1 over 3 plus 1 greater than 0. If I subtract on top, I get -4 over -2 greater than 0. Well, that's 2 greater than 0. This is true. So this area is solutions. Here I get -1 over 1, which is -1 greater than 0. That's not true. So these are not solutions. And then in this situation, this will be 2 over 4 greater than 0. Well, that is true. So these are solutions. So our solutions are going to be from -infinity to -1, and then from 1 to infinity. So we should write that as -1, comma, other way around, -infinity, comma, -1, parenthesis on the -1, and then union 1 to infinity. That's how you solve rational inequalities.